So, how do we save civilization? We get information from an outfit called the Minor Planet Center, which is in Cambridge, Massachusetts. They send us basically a list of things that they want more information on. And when we are able to, we take images of that area of the sky and do the digital combination of the images and blink them. Something jumps, we compare it with another direction and speed, throw some software at it, eventually send some data back to the NBC, and they do a computation to extend the known segment of the orbit and rate the object on the Torino scale. And it was this that brought Apophis down from a 4 on the Torino scale down to like a 2 or something. Now, while we're at it, every once in a while, how is this saving civilization? Oh, okay, this is where I brag a whole bunch more about what we do. The Minor Planet Center can update its library of known NEOs. It can effectively re-find lost asteroids. Of course, provide predictions about where they're going in the future, identify any new, what they call PHAs, which are potentially hazardous asteroids, and monitor changes to orbits due to various influences, like that one that just buzzed by us here on October 8th. We'll be watching that one to see what happens to its orbit. As of 2001, we became the second most productive observatory in the world doing this kind of work. And I've already mentioned Apophis. They specifically requested that we look at that one because of the size of the Risinger telescope and the quality of our previous work. We have over 9,300 NEO observations now. This statistic is several months old, so I'm sure that number is much larger. It's probably over 10,000 by now. Second only a federally funded Lowell Observatory, but I think probably the ultimate compliment we were paid was that the guy that we had some years back that was doing the bulk of this work, just, again, as a hobby, got hired by the Minor Planet Center to move there and work on this stuff full time. While we're at it, we've discovered a few asteroids, and as I mentioned before, if you discover it, you get to name it. This originally started out as 2000 VG38. It is now asteroid 25890 Lewisburg. And here it is. If it were perfectly clear tonight and we could shut all the lights in Kansas City off and use the 30-inch telescope out of Powell, we might actually be able to see it. But since none of those things is true, we won't. But this is where it is right now. It's just a fairly regular main belt asteroid, about 7.5 kilometers in diameter. It takes about 4 years and 8 months to go around the sun. I tried to calculate the black body surface temperature of it and came up with what looks to me like kind of a high number, but it's still pretty chilly out there. Surface gravity is teeny tiny. 100 pounds on Earth is 9/16 of an ounce on that asteroid. Okay, now for a really fun event that proved that the system is working. Just over a year ago, there was a successful prediction of an asteroid impact for the first time. This was on Monday, October 6th of 2008. This body was discovered less than a day before impact, and it was one of the automated surveys that picked it up. Something like 586 astrometric and almost as many photometric observations were performed by 27 amateur and professional observers in less than 19 hours, reported to the Minor Planet Center, which issued 25 minor planet electronic circulars with new orbit solutions in 11 hours as observations poured in. And they were able to pinpoint where it would hit. And when it hit, it was observed by a KLM aircraft crew. It was like way over here somewhere, and an infrasound array crew down in Kenya picked it up. So they knew that it was up there somewhere. And here's kind of a fun thing that came out afterward. This is in a beach house on the Red Sea up somewhere in here. Had a webcam going and not pointed toward where the asteroid was coming, actually pointed in the other direction. But 30 seconds before everything's dark except a light on a boat out in the Red Sea, but during it, it lights the whole landscape up here in the middle. And then afterward, it's dark again. It's just 725 kilometers from the impact. It's about as far away as Kansas City is from Chicago, and it lit the whole landscape up. And there's an animation, which is Of course, you know, what the heck, it's just an animation, but still, let me back this up and grab this off of here, and we will jump out here and show it. This is out on YouTube. And this is just an asteroid's eye view. Ironically, they took this from an image of Itokawa, which is hundreds of times bigger, but they just wanted an asteroid shape, so they put it in. And here we have the distance coming steadily down. This is coming over Africa. And you basically just see what you would have seen if you've been riding along in the last few minutes as it came in. This is sped up in real time quite a bit, but it's the trajectory that it followed. And basically it comes in over the desert, and eventually gets down really low and vaporizes. Okay, here, and to here. Okay, and this is its final orbit. It would have been coming up like this, so again, the lighter turquoise is north of the plane of Earth's orbit, so it was kind of coming in from a slightly northerly direction, and it hit us right there. And a few months later, they started finding pieces of it on the ground. They originally did not think they would. That photo on the left is the morning of the impact, showing the vapor trail from it. And somebody organized a bunch of students from the University of Khartoum, among other places, and they just went out in the desert right below where it blew up, and lined themselves up and started walking along looking for dark rocks. Most asteroids, or most meteorites, are found in deserts or in Antarctica or in Greenland because they show up so well against lighter material. They're usually very dark rock, and in fact there's a piece of it right there as it was found in context. Here's my fun alternate history slide just to underscore again that whole geopolitical risk point. Not only did it come in here and do this instead of doing something like this or this or this. The really interesting thing about this to me is that it happened close enough to some really sensitive parts of the world that it may have raised awareness of the problem and inadvertently made us all a little bit safer. Okay, that's everything about asteroids, and now the ASKC commercial. We want you to join the ASKC because we have lots of fun. We do, as I say here, monthly meetings with great speakers and knowledgeable club members. And in fact, let me show you what you're missing right now. I mean right this minute, while you are sitting out here in Johnson County listening to this total amateur drone on about asteroids for an hour, here's what you could be doing instead. You could be down at UMKC listening to this guy talk at the meeting that's going on right now. He's a professional astronomer, and he's written all these books and done tons of cool stuff. And he's probably talking about, I imagine he's talking about his latest book there at the meeting. So we do lots of cool stuff at the meetings. Not to overlook the obvious, we run Powell Observatory. We also run a smaller observatory on the roof of Royal Hall at UMKC called WARCO for short. That's open on Friday nights to the public, May through October. Powell is open Saturday nights, May through October, to the public, and you can reserve it any other night of the year, year-round. In fact, Bill's class is going to be out there in a couple of weeks. And if you join, you get to use that Lewisburg Community Telescope. It's the tube in the big metal shed. You can become a key holder and actually operate the big telescope. Training is always available. You get access to a dark sky site, which is a 40-acre property we have down in Overland, Missouri, where we do a star party every year. In fact, that just wrapped up last weekend, I believe. And of course, as I've been talking about, you can help refine asteroids' orbits and save civilization. And that's it.